Okay, good morning students. In our geometry we have learned about triangles already in the name of 8th chapter similar triangles. We have learned about similar triangles. Here in that similar triangles we have learned about different triangles and the properties of two triangles or three triangles we have learned. In that similar triangles we have learned about one of the triangle called as right angle triangle. If we need to discuss about Pythagoras theorem, the Pythagoras theorem is defined on a right angle triangle. Now again, if we consider that right angle triangle, take a right angle triangle. Suppose ABC is a right angle triangle, right angle at B. ABC is a right angle triangle, right angle at B. Suppose C is the angle. Here I am taking the angle is some theta. Angle is theta, Greek alphabet theta. According to theta, here AB becomes opposite side. AB becomes opposite side to theta, and BC becomes adjacent side to theta. And as we know, in a right angle triangle, greatest side is hypotenuse. As we know, in a right angle triangle, greatest side is hypotenuse. See, in this right angle triangle, if we try to write the ratios, between the sides, opposite by hypotenuse, we can write one of the ratio, and next adjacent by hypotenuse also we can write adjacent by hypotenuse, and next opposite by adjacent, and the next one is opposite by adjacent. So we are getting three different ratios. For these three, with the help of these three different ratios, we will form more three ratios: opposite by hypotenuse, nothing but hypotenuse by opposite, reciprocal of opposite by hypotenuse, and adjacent by hypotenuse, nothing but hypotenuse by adjacent, and opposite by adjacent, it's nothing but adjacent by opposite. So in this way, if you take a right angle triangle, we are aware of 6 different ratios. So every time writing opposite by hypotenuse or adjacent by hypotenuse or opposite by adjacent, it is difficult for us. So we need some name for these ratios. For that purpose, the mathematicians named these ratios. First, they named this ratio as SINE sine of theta. For our convenience, we can write it as sine theta. And the next one is cosine theta. They named this adjacent by hypotenuse as cosine theta. For our convenience, here also we can use it as cos theta. And the third one is tangent theta. Nothing but tangent of the angle. For our convenience, we can write this as tan theta. So in trigonometry, we can take these three ratios as a basic ratios or main ratios, and the next three ratios, these three ratios depends on these three ratios. So these are called sub ratios or reciprocals to the main ratios. First one is sin theta. Sin theta is equals to opposite by hypotenuse. So its reciprocal defined as cosecant of the theta, nothing but cosec theta. In our general language, in our general usage, we can use it as cosec theta. And the next one is adjacent by hypotenuse, nothing but cos theta. Its reciprocal is hypotenuse by adjacent. This defined as secant of theta, nothing but secant theta or sec theta. Last one, here it is the reciprocal of tangent. We can name it as cotangent of theta, nothing but simply cot theta. So these are the 6 ratios. From where are we getting these 6 ratios? In a right angle triangle, we are defining these 6 ratios. Where we use these 6 ratios, means any separate branch is there or any separate topic in a mathematics, or what we have to know? Yes, it is separate topic in mathematics. This topic name is trigonometry. What is the meaning of trigonometry? 3 angle measurement. If we consider the triangle here, we have 3 angles. 1, 2, 3. So the 3 angles measurement. We are discussing about the measurement of angles with the help of sides. See here, sin theta. We are calculating the value of theta with the help of 2 sides. In the same way, if you observe any ratio, we are discussing about the angle with the help of sides. So the relation between angles and sides we will discuss here. Not only in right angle triangle, in any triangle we will discuss, but basically these ratios defined in right angle triangle. If we talk about sin theta, this sin theta first time used by our great Indian mathematician Aryabhatta. He was used in astronomy. So afterwards, later on, this all they used. And if we go to the history of trigonometry, the spelling of trigonometry is trigoniometry. Trigonometry. Trigonometry. If we see separately, we can write like this. Trigonometry is nothing but gona, nothing but gonia, and metry is nothing but measurement. This word taken from Greek language. What is the meaning of tri here? Tri is nothing but 3. What is the meaning of gonia? Gonia is nothing but angle. Metry is nothing but measurement. 3 angle measurement called as trigonometry. Right? Here we can take Hipparchus. We can consider Hipparchus as the father of trigonometry. Here we have just basics in this chapter. Okay? Right. So here we are writing sin theta as opposite by hypotenuse, and immediately its reciprocal cosec theta is equals to hypotenuse by opposite. Sin theta is equals to opposite by hypotenuse. Cosecant theta is equals to hypotenuse by opposite. From this we can get the relation sin theta into cosec theta is equals to 1. Sin theta into cosec theta is equals to 1. Opposite and opposite gets cancelled. Hypotenuse and hypotenuse also gets cancelled. Sin theta into cosec theta equals to 1. And if we see the next one, cos theta is equals to adjacent by hypotenuse. Cos theta is equals to adjacent by hypotenuse. Then secant theta is equals to hypotenuse by adjacent. Secant theta is equals to hypotenuse by adjacent. From this we will get the relation cos theta into secant theta is equals to 1. And the next one is tan theta. Tan theta is equals to opposite by adjacent, and its reciprocal cot theta is equals to adjacent by opposite. From this we will get the relation between tan and cot, that is tan theta into cot theta is equals to 1. Right? Now here if you observe this one, sin theta into cosecant theta is equals to 1, whereas sin theta is equals to opposite by hypotenuse, and cos theta is equals to adjacent by hypotenuse. If we divide these two ratios, means if we write like this, sin theta by cos theta is equals to opposite by hypotenuse whole divided by adjacent by hypotenuse. As we know, hypotenuse and hypotenuse gets cancelled. What are we getting? Opposite by adjacent we are getting. Opposite by adjacent we are getting. But according to the definitions, opposite by adjacent is nothing but tan theta. Opposite by adjacent is nothing but tan theta. So we can write tan theta is equals to sin theta by cos theta also. Okay. Next, similarly, its reciprocal. What is the reciprocal of tan? It is nothing but cot theta. So we can write cot theta as 1 by sin theta by cos theta. 1 by sin theta by cos theta. It is nothing but cos theta by sin theta. It is nothing but cos theta by sin theta. And one more thing, here we are writing tan theta is equals to sin theta by cos theta. Same tan theta can be expressed as sin theta is nothing but 1 by cosec theta. Sin theta is nothing but 1 by cosec theta from this, and cos theta is nothing but 1 by sec theta. Cos theta is nothing but 1 by sec theta. So as we know, the denominator of the denominator becomes numerator. So here secant theta becomes numerator by the denominator is cosec theta. So tan theta is equals to secant theta by cosec theta. Similarly, cot theta. As we know, cot theta is the reciprocal of tan theta. So we can write here cosec theta by sec theta. Okay. We will see some examples. Suppose we have given sin theta. Sin theta is equals to some 3 by 5. Sin theta is equals to 3 by 5. Then we need to calculate the remaining ratios. We need to calculate the remaining trigonometric ratios. First ratio is cos theta, and the next one is, second one is tan theta, and the third one is cosecant theta. Next, fourth one is secant theta. Sin theta is given already, so we need to calculate cos theta, tan theta, cosecant theta, secant theta, and one more also we will calculate cot theta. Cot theta. How do we calculate this? Sin theta is equals to 3 by 5 is given. So we will write first what have they given in the question. They have given sin theta is equals to 3 by 5. Sin theta is equals to 3 by 5. So here if we draw a right angle triangle where A is right angle at B, ABC is right angle at B, and we can consider C as theta angle, and we know that sin theta is nothing but opposite by hypotenuse. So if we write this, theta opposite is 3 and theta hypotenuse is 5. We need to write the remaining ratios. We have to calculate the adjacent side. We have to calculate the adjacent side to theta. First to calculate that one. Already we know in triangle ABC by Pythagoras, what we get? AC square is equals to AB square plus BC square, because the statement of Pythagorean theorem is in a right angular triangle, square of the hypotenuse is equals to sum of the squares of the other two sides. So here AC square is 5 square is equals to AB square. AB is 3, so 3 square plus BC square. 5 square is equals to 25. 25 minus 3 square is 9 is equals to BC square. 25 minus 9 is equals to 16. So BC square is equals to 16, and BC is equals to root of 16, that is equals to 4. Positive root should be considered here, positive square root. So BC is equals to 4 we are getting. Then what have they asked? They asked to calculate cos theta. So if we write the cos theta formula is adjacent by hypotenuse. Cos theta formula is adjacent by hypotenuse, adjacent to theta by hypotenuse. What is adjacent to theta here? 4 by hypotenuse. What is hypotenuse? 5. And if you see the second one, what is second question? Tan theta. What is tan theta formula? Tan theta formula opposite by adjacent. Opposite to theta by adjacent to theta. What is opposite to theta here? 4. Sorry, opposite to theta is 3. Adjacent to theta is 4. 3 by 4. And next, if you see the question number 3, what is question?